Temperature. It's what makes us hot. Well, at least that's how I feel sometimes, at least during the summer. Oh, look at all these circles again. They're actually labeled this time. You all know what that means. We conjecture ahead.
Although this is going to be weird, and it's going to be about a different.
Title of the conference was something like Ground Truth or Turtles All the Way Down. And so it seems as though there's one Ruliad. I don't think it rules them all. And it might be just hyper turtles all the way down.
Yes, it's on the back of an infinite number of hyperruleal turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Hey guys, what's going on? Memes here. Welcome, Whitechapel. Thank you for joining, my friend. We're going to be rounding up our little video series on geometric derivations of the Planck units, and that's going to be a claim here and everything, just because it seems to be working. It's in a new kind of, some may say science, if you would, basically utilizing things of the past and things presently, tools such as Wolfram Alpha. Thank you, Professor and Team Wolfram. But what are we going to go into? And again, links, of course, are in the doobly-doo below. I actually remembered to put Thad's video to 44. This is where he kind of goes over most of the things here in that video there. If this is your thing, it might be worthwhile. Spent a lot more time thinking about this than me. It's literally like he's helped power level me. It's like being in World of Warcraft. It's like you have a higher level player around you, got a lot more experience. They can bring you up to speed a lot faster for even noobs like me. But all right, let's jump right into it. Again, we've been going through this. Literally in Google, it's like you have visited this page many times. The Planck units here, and again, we go through this. We go through all the derivations and everything. Okay, and then okay, the Planck temperature. What we got here? All right, Planck temp. Ooh, it's got an interesting. What is that? Like a theta or something? Huh, nifty. But oh, degrees. But okay, the temperature Planck. Hey, welcome, Laura. Is equal to the square root, and again, it's very interesting. We're getting the square roots of these. Like I think at one point, Professor Carroll was like, "Yes, within physics, you're like you get a number. It's like you don't know what happened. Square it, cube it, square root it. It's like just seems to be a thing. We will get into why that may be the case at a later date. Um, okay, so we got the square root of h bar. So that's the reduced Planck's constant times the speed of light raised to the fifth. I like the number 5. And that's all divided by the gravitational constant. And that's times the Boltzmann constant squared. Boltzmann constant, entropy, temperature. Imagine my shock. See what I did there. But okay, that's cool. But yeah, and the number we're looking for, again, it's there. Number we're looking for is the value of 1.416784 error bars of 16, the last 2 digits there, times 10 to the 32 Kelvin. That's really freaking hot. It's like, what is it? The surface temperature of the sun's about like, I don't know, like 6,000 degrees Kelvin, depending on where you are, maybe like 10,000 degrees Kelvin. That's freaking plasma. That's like 10 to the fifth. Yeah, that's got like 27 more like digits after it. It's literally a theoretical temperature where we're assuming that's kind of like at a Big Bang style state in order to achieve those energy levels. Basically, at that point, when you start to model things, this is something that Enresto's been kind of bringing up recently. Is literally your wavelength is like 1 Planck. It's like we don't really have a model to go past that. Perhaps the Wolfram Physics Project can help give us a little bit of a clue, because I believe Professor Wolfram said that the elementary length in that model, they're estimating for 10 to the negative 100. That's really freaking small. Yes, yes. At this point, Laura, yes, it is very hot temperature. But okay, we're gonna go into our little thingy over here again. We got our circle. I probably really should have shown this the first time because it actually has things labeled. It makes things a whole lot less confusing. I need to go through the whole book again and everything. And maybe with ChatGPT this time, it seems to teach me. It's kind of like the Googles were, except like it actually like phrases things back, and you tend to have less ads. But okay, as we can see written here, the internal and external boundaries of balance 4. Boundary 4. And I believe boundary 4 to the -1. Oh, we got an inversion in there. Or under inverse action. Oh, look, it even says that. Okay, so what do we got here? Our minimum skip. Balance 0 is basically the Planck time. Then to the -44 seconds approximately. Uh, okay, then we got balance 1. Okay, that's our minimum scale. This is basically the Planck length. So basically, you got time, you got space. I'm also noticing now that that seems to be a central point. I think Roy, I'm not saying that the central point of non-motion, of stillness, some may say. I'm, I'm just talking off the top of my head. Take it for what it's worth. Okay, so and then once we get over time, space, you got to have charge. Balance 2, the charge. So we start having that acting upon there, and basically this particular diagram would continue to extend that, and I'm still making sense of it myself. Gordon brought this up. It's need to explain this in a better way. I think with at least some labels and it being on screen for a little bit should probably help. I know it's helping me. But okay. And then that's charge. What's third balance here? Oh look, it's kind of the same over there. It's the mass boundary. What we did the other day. So essentially the external reference point, the claim is of our realm of persistence, what many people colloquially refer to as universe. Yeah, it's going to be basically about 10 to the -8 meters. Meters like, you got a centimeter, it's like, so that's 2 powers lower. We need to go 6 powers lower. Really freaking small. It's like around the size of like a plant cell or something, but that's something you can actually like view in a biology class on a microscope or something. Okay. And we got balance 4 here. This is a temperature domain. I believe colloquially within ADS CFT correspond, it's the whole Professor Maldacena thing where it's like, all right, it's a flat universe, and that at least to us, if it's large enough, it's basically like a flat surface. Basically, we're in a ginormous hypersphere. That's essentially the claim. Within general relativity of the n hypersphere maximal volume. It's essentially a four-dimensional hypersphere. Uh, I am going off on a tangent, but yeah, this is 10 to the 32 meters. That's the claim. You got that power there. I think Thad had mentioned this. And then I'm pretty sure at one point I just naively threw some Planck units in there and I came up with this. I did a video, I don't know, like 7, 8 months ago. It's like, is the universe like 15 quadrillion light years? It it looks like it's just under that, approximately. That actually might just be the radius. Crazy thing. But so basically, you got a whole bunch of spheres, little tiny infinitesimals. They're not zero, but there is still a magnitude there. And then once you hit basically our realm where the claim is we see the stuff that we exist in. Basically our Earth, our Milky Way, our cluster, our literal realm of persistence is about 10 to the 32. It's about 168,000 times larger than our current observable universe. Like what do they say, 93 billion light years? I think that's what we got. Hey, T Carr, welcome. Thank you for joining, my friend. We're just finishing off our little Dragon Ball anime Planck constant thingamabobber here. Okay, so you got the projected external realm here. Yes, I'm not going to blow you on this much longer. But basically, think about this. You know, series of circles, and then you got a ginormous circle, and it's just kind of, I don't know. This is why anime helps me, because it's like, I might not have the formal training and everything, but it's like, I can see Naruto form a Rasengan. Seems to be a heavy articulation raising to a hypersphere of energy. That makes sense to me. When you tell me it's like the electron is a particle, it's a point particle, but it exists in all these places at once. I'm like, that doesn't make much sense to me. If you're like, it's an energy sphere, I'm like, I have a model for that in my head. At least that works for me. But okay, that's enough of that. So we'll go over to our little thingy, which anyone that actually clicks this video is probably what they're looking for. But okay, we got this thingy here. We got logs again. Jen was totally right about the logs. But there are interesting questions here because I made the claim the other day that basically we end up getting those base powers of 10 because of double cover of 5 ingredients. We get the answer using the natural log. Is that an exact equivalent? I don't know. I need to parse it more, but I don't know. I just think it's interesting that these things happen, and we want to be open and transparent as much as we can. And you're just gonna like hide any potential things that people can poke at. It's like, come on. If you're actually searching for the truth, you want it to be true, even if your current understanding is wrong. We all make mistakes. How we handle them is what defines us. I did that on purpose. I also think it's true. Okay, so what do we got? So we got two hyperbolic cosines. Take the log of 7. So we basically have our break and scale symmetry right there. Cool. And then we multiply it by the hyperbolic cosine squared. 5 divided by 2. So our 5-dimensional ingredients divide by 2, multiplied by the cosine squared. 7 divided by 5. So our break and scale symmetry. So basically our first circle over here, or excuse me, our next iteration of the circles. You have 6 circles surrounding that inner circle. That's 7 circles. That's where we get the blue bee within Thad's book and the model we're using of the minimal arena. I colloquially refer to as the HF8 model. All right. So then we have, oh, yep, break and scale symmetry divided by the 5-dimensional ingredients, and then like the rest of them. We multiply it by E, the base of natural logarithms, aka Euler's number. And we raise it to the X that we're going to solve for. That's the claim is, that's the magnitude of the rotation. And we set it equal to the number of derangements participating in this balance. That happens to be 32. And again, the claim is, this is a double cover, when we set this up, we're kind of getting that times 10 raised to this here. That's the claim. So we'll see. Okay, can rewrite as that. Let me get this number over here. All right, what is this number? What were we looking for again? Planck temperature. We're looking for this. 1.416. Oh, zoom. 1.416. 784. 786. Okay, we're off. Okay, so last 2 digits. So that 8 go up to a 9. Actually, that whole thing I guess could go up to an 8 right there. 9 are down to 7. So 84 was 16. And the last 2 digits. 84. Oh, 86. Okay. My friends, appears to be a geometric derivation of the Planck temperature. Or at least that's the claim. And seeing as at least, and again, I'm totally biased. I am totally biased on this. At least the time I've had with this, it seems to be able to reproduce the parameters of quantum field theory. That finished doing at least a first run through of chemistry, and the continents of information and data you start seeing in these relations. I do like the imaginary continents. Oh God, the tower powers of I are fantastic. We'll get into that very soon. It's I think it's starting to make a lot more. I didn't even know how we would go about this. That's like we're gonna use it, and he didn't know either. It's like well, I just figured we just take those base things and just do the standard thing like we normally do. We just build upon this, build upon that. Kind of seems like what it is, at least for the periodic table. Apparently, everything is mostly just composites of hydrogen and helium because it's stable. And I don't know. Does that explain beta decay? I don't know. I guess we're gonna have to find out at some point. But oh god, no, we're not gonna teach Fizz the shadow. Oh god, we're going to do that. We will do that in a comic that I've totally forgotten to send Pipe for Pipe. Oh god, but yeah, that's all we got for right now, folks. But all I know is it's a wacky and wild world out there. But I think there's some really good stuff coming sooner rather than later. And again, all shows. Actually, Professor Wolfman was kind of saying this earlier. It's like, well, even if this doesn't necessarily have a practical use, it might be good for video games. So I'm pretty sure the future will be awesome. So I know you all are. Peace out, everybody.